So we're going to start 2.2. You can find all the notes on Canvas. Very well. When you click on Math 10, you can go to Modules on the left-hand side. Then we are on week 1 of the class. Chapter 1 note, we're done with it. Chapter 2 note, click on that. There are PDF files for you. You're done with 2.1. Now click on 2.2. You can download this file. You can print this out. Very well. I downloaded the file. I'm sharing the PDF file with you.
How to find the collaboration? I didn't find.
Very well. So far we talked about asking a question in statistics, asking a question. Then we start collecting the data, collecting data. In this step, which is the third step, you're interested in visualizing the data. So yesterday we mentioned that to visualize the data, you can use either a frequency table we learned how to form and construct a frequency table. Then we learned how to construct a relative frequency table. Today we're going to talk about charts and graphs. There are different methods in statistics to form charts or graphs. So in statistics, there are different methods to construct a chart or graph. That depends on your variable. It depends on variable. Again, we're getting back to chapter 1. Remember, we talked about variables. When we talk about variables, a variable can be either a number, numerical, quantitative, or it can be categorical, qualitative. Depending on which variable we have, we're going to use a different graph or chart. Very well. Our very first method of visualization after a frequency table is using stem and leaf plot. I'm sharing my screen with you to go over the very first example in 2.2. Our goal is to construct a stem and leaf plot. The data set lists the numbers of text messages sent last week by the cell phone users on one floor of a college dorm. Display the data in a stem and leaf plot. Describe any patterns. So here we have a collection of data. We're going to try to use stem and leaf plot to visualize these data. Well, how do we form and construct a stem leaf plot? Stem and leaf plot. There we go. So we try to categorize the numbers based on the digits that they have. For example, let me write stem here and leaf here for you. For example, if you have some number like 15, 1 is going to be the stem, 5 is going to be the leaf. 15. If you have a number like 155, 155 with 3 digits, 15 is going to be the stem, and 5 is going to be the leaf, and so on. So in this example, we have a lot of numbers. We need to identify each of them, then categorize them based on stem and leaf method. Very well. Example, and note that we are on page 1. Okay, so
Question?
okay guys, so let's take a look at our data here. Let me erase this. I'm going to write down the numbers that we have here. We have, let me see, 155, 155. Just illustrate the collection of the numbers that we have. 155, 159. We have 144, 129. We have 105, 145, 126. What else do we have? 116, 130, and 114. Then next, you have 122, 112, 112, 142, 126, 118. Then you have another 118, 108. What else do we have? 122 and 121. Then you have on the third row 109, then 140, 126, 119, 113, 117, 118, 109, 109, and 119. So this is our third row. Let us move on to the fourth row. 139, 139, 122, 78, 133, 126. What else do we have? 123. We have a lot of numbers here. 145, 121, and 134. And finally, let's get to the last row, which is 124, 119, 132, 133, 124, 129. Then you have 112, okay, 126, 148, and also 147. Okay, so these are the numbers that you have. There you go. So let us identify all the leaves here. Here we have 5, we have 9, 4, 9, 5, 5, 6, 6, 0, 4, 1, 2, 8, 8, 8, 6, 2, 2, 2, 2, 9, 0, 6, 9, 3, 7, 8, 9, 9, 9, another 9, 9, 2, 7, 3, 6, 3, 5, 1, 4, 4, 9, and I'm sorry, this is 2, just 2, 3, 4, 9, 2, 6, 8, and 7. So let us identify all the leaves that we have. We already identified all the stems that we have. So we have 15, 15, 14, 12, 10, 14, 12, 11, 13, 11, 12, 11, 11, 14, 12, 11, 11, 10, 12, 12, 10, 14, 12, 11, 11, 11, 11, 10, 10, 11, 13, 13, 12, 7, 13, 12, 12, 14, 12, 13, 12, 11, 13, 13, 12, 12, 11, 12, 14, and finally 14. So what are we going to do? We're going to use a vertical line, So the maximum stem is, let's find the maximum stem. Is it 15? The maximum stem, guys, am I on the right track? Is it 15, the maximum one? The highest stem is 15 or not? Do you see any? It is? Okay, perfect. So this is your maximum. What's your minimum stem? Minimum stem?
0.
0, you're looking for the stem here.
Oh, sorry.
Is it 7?
7.
Yes, we don't have any number less than 7, huh? So 7. So you have 7. We can list the rest of the numbers in the middle. 8, 9, 10, 11, 12. I think I need more space here. 7, 8, 9, 10, 11, 12, 13, 14, and 15. So what are we going to do? Now we're going to list all the leaves that we have. We have 70, where does it? 78. So the leaf goes here. We don't have any 80s. We don't have any 80, 81, 82, 83. So we're not going to write anything here. Leave it blank. We don't have any 90s. We don't have any 90, 91, 92, 93, nothing. So leave it blank. How about 10? Okay, let's look for 10s. So I have 1008. I have, so 1008. I have 1009. 1008, 1009. I have two 1009. What else I have? I have 1009, another 1009. What else I have? I have, do I have any other 10s? Is that it?
1005.
1005, okay, where is that? Oh, I didn't see that, thank you so much. 1005, that's why I need your help. You need to help me to identify and find all of these numbers. Okay, so I have 1005, 1008, 1009, 1009, 1009. So I have my 10 here. I'm going to write 5. I'm going to write 8. I'm going to write 3 9s. 9, 9, 9. Now let us find all numbers which has stem 11. Okay, guys, help me find all of them. One of them is 116. The other one is 114. Okay. 112. Okay, I have two 112. then 118, 118, 11.9, okay, 11.13, okay, let me see this guy. So 11.13, 11.14, 11.7, 11.8, another 11.8, and 11.9. Let me go here. I have to find all of them. Well, another 11.9. Okay, excellent. Then I have 11.2. That's it for me. Are we good?
Yes.
Okay. Now next to 11. Sorry, we write 2, 2, 2. 2 is repeated 3 times. So 2, 2, 2. 3, just one leaf as 3. 4, just one leaf as 4. 6, 1, 6. 7, 1, 7. How many 8s do I have? 3 of them. So 8, 8, 8. And here you have 9, 9, and 9. Very well. So now that we feel comfortable about finding all of these, how about 12? We need to find all of the 12s. So I have 12.9. Then I have 12.6. I have 12.2. I have 12.6. Another 12.6. I have 12.2 again. I have 12.1. Okay, I didn't see this guy. Then I have 12.6 again. I have, let's see, 12.2. Then 12.6. 12.3. Okay. Then I have 12.1. Okay. Then I have 12.4. I have 12.4, another 12.4. Then I have 12.9. I have 12.6, another 12.6. Okay, and that's it. So I get 2 1s next to 12. 3 2s. 1, 2, 3. 1 3. 2 4s. 1 2 3 4 5. 5 6. And 2 9s. Okay, now what about 13? Let us find all of the 13s, then we move on to 14s and 15s. So let's see, 130. Then I have, let's look for all of them. Oh, 134, okay. 133, 139, 139, and let's see, 132, another 133, and we're done. So in front of 13, we're going to write 0, 2, 3, 3, 1, 4, 9, and 1. Excellent. How about 14? Let us find them all. 14.4, 14 and 4, 14 and 5. Then we have 14.2. Then we have, okay, 14.0. Okay, perfect. What else I have here? I have 14.5, another 14.5. And I have, let's see, 14.7, 14.8. So 14.0, 2, 5, 5. Oh, we have a 4. So 4, 5, 5, 7, and 8. And finally, 4.15. Very well. What do we have here? 15.5. So let me write it here. Maybe we have smaller numbers. 15, 9. Do I have any other 15 here? Not here. How about here? Nope. Here, nope. And is that it? Yes. 5. And this is your SEM plot. Let us take a look at the note on page 2. They have constructing a dot plot. So we have a collection of numbers, which are the numbers that we have in example 1. Now we're going to use a different method to visualize the data. Well, how do we form a dot plot? So let me just erase these. We are on page 2. We're going to form a dot. So dot plot. So when we have a dot plot, it's very simple. It means that you just use a dot representing these numbers. How do we do that? To construct a dot plot, we use dots for each value. So let's take a look at this. The minimum value that we had here was 78. So let me just erase these, avoid any confusion. We are just using the exact same collection that we had before. Nothing is changing here. I'm just erasing these circles, because these are all numbers. We don't need these circles representing these numbers. We're just going to use the actual numbers and dots to visualize the data. Okay, perfect. A little bit more of these. Nine, 5. Okay, 2, 4, 9. Another 9. Okay, almost done. Excellent. So the smallest value that we have in our collection is 78. So 78 is the minimum value. And the maximum value is 150. Is it 155, or do we have a larger number? 159. Thank you. So 159. So here we're going to form a horizontal line. Just shift it a little bit down here. I might need more space. So 78, the minimum value, and also 159, the maximum value. Okay, let us just scale this. So here you have 78. Let us have 80 here, 90 here, 100, 110, 120, 130, 140. It's just scaling, that's fine. 150, 140, 130, 120, 110. This is good. Then here we have 90. Then here we're going to have our 80. And we're done with scaling. Of course, to get a precise dot plot, it's better to use a software. So let us begin. We have 78. It means that we put 1 0 or 1 dot for 78. Next number, 155. 155 is randomly here. Then you have 159. 1 dot for 159. 144. Where is 140? 144 is roughly here. Then you have 129. Where is 120? 129 is close to 30. Then you have 105. It's close to this guy's here. So 100, 110, 105. Then 145, 145. So here we have 144, 145. It's going to be close to 144. Then you have 126. 126 is going to be roughly here, and so on. So you start using these numbers and dots representing each of them. Okay, take your time. Try to form the dot plot. When you construct your dot plot is going to be like this dot plot here. And as you can see, the majority of the data, the number of dots, they are clustered between 105 and 148. So most of your data entries or these numbers are clustered here. What's the meaning of that? It means that you have some outliers. What are outliers? This point here is an outlier. It means that it's far away from most of the data.
155 and the one.
So as you can see, 78 is very far away from the most of the data that you have. We call this an outlier or an unusual data entry. Later on, we're going to learn about unusual data entry and highly unusual data. We're going to learn algebraic techniques to actually identify those unusual values. Well, on page 3, we're going to learn how to actually graph qualitative or categorical data using a pie chart. Here we have an example constructing a pie chart. The numbers of earned degrees conferred in thousands in 2011 are shown in the table. Use a pie chart to organize the data. So we are on page 3 and we are working with categorical or qualitative data. In this case, you have degrees. So page 3, using a pie chart for categorical data. So next one is a pie chart. So how do you form a pie chart? Let me write down the categories that we have and I show you how to construct a pie chart. So here you have categories which are type of degree, the first category is associate's degree. The second category is bachelor's. Then we have master's. And finally, we have doctrinal. Okay, so what is the frequency or count or number of each of these categories? Number.
The little blow pockets. This had no blow time. It got pulled over. Didn't even see it.
Really? What did they tell you?
So let's see. The number in thousand or the frequency. There you go. The frequency of the first category is 942. It means that the number or frequency or count of associate's degree is 942. You have 942 of them. The second category, 1,716 of them. For masters, you have 731, and for doctoral, you're going to have 164. Very well. What's the next step? Next step is actually to form your relative frequency. Now, construct relative frequency for each of these categories. So the first category has frequency 942 divided by. The second category has 1,716 divided by. The third category is 731 divided by. Then last category is 164 divided by. So divided by what? What is the number that we are dividing these by? What's your guess?
I think it's the including all of the associate.
We're looking for our denominator. The denominator is actually the sum of all of these frequencies, which is
3,553.
53. Excellent. Thank you very much. So we are forming relative frequency. We have to divide each of these by 35, 52. 35, 53, 35, 53, 35, 53. We get our percentage. It helps us to actually construct our pie chart. So the first one is going to be 0.265 or 26.5%. The second one is actually 0.483, which is 48.3%. The next category has a relative frequency 0.206 or 20.6%. And finally, you have 0.046, which is equal to 4.6%. Very well. Let us take a look at our pie chart. Our pie chart is this beautiful pie with some portions which include associates, bachelors, masters, and doctoral. As you can see, the majority is for bachelors. Very good. Okay, now how do we use angles? To use angles you have to multiply each of these relative frequencies or percentages by 360 degrees. Let us take a look at it. So I'm going to just erase these decimals. I need more space. So here you have 26.5%, 48.3%, and here you have 20.6%. Here you have 4.6%. Now, to find the angle, we're going to multiply each of those relative frequencies by 360 degrees. Multiply each relative frequency by 360 degrees. Very well, let's do that. 26.5% times 360 degrees. Then you have 48.3% times 360 degrees. Then you have 20.6% times 360 degrees. And then you have 4.6% times 360 degrees. Okay, the angles that we get, the first angle is 95 degrees. The second angle is 174 degrees. Then you have 74 degrees. And finally, you have 17 degrees. Very well. So last time we saw histogram. This time we're going to talk about bar chart and Pareto chart. Bar chart.
Bar chart?
Yes, and Pareto chart. Note that I'm just separating these. I'm adding histogram here. Stem and leaf, dot plot, histogram, those are all for numerical values. Numerical values, or another name, quantitative. These charts are for categorical or qualitative. Okay, so we're going to construct a bar chart, we're going to construct Pareto chart, and we're going to take a look at some examples. Let us get back to our note. We are on page 4. In this example, we're constructing a Pareto chart. In a recent year, the retail industry lost $34.5 billion in inventory shrinkage. Inventory shrinkage is the loss of inventory through breakage or pilferage or shoplifting and so on. So it divides into different categories. Guys, note that even though you have numbers, our main focus is on categories, categorical values. The main causes of inventory shrinkage are administrative error, the first category, administrative error. How much? 4.2 billion. Employee theft, 15.1 billion. Oh, wow, that's huge. Shoplifting, 12.3 billion. Unknown, 1.1 billion. They couldn't recognize and categorize that, so it's unknown. And finally, the vendor fraud, which is 1.7 billion. Question says, use a Pareto chart, which are just bar charts ordered from the largest to smallest chart to visualize the data. To construct the Pareto chart, the category with the highest frequency, take a look at these numbers. The maximum number is 15.1 billion, which is for category employee theft. So employee theft comes first as the first bar with the highest frequency, which is 15.1. The second one is going to be shoplifting, because the number after 15.1 is 12.3, shoplifting. So shoplifting has frequency 12.3, forms the second bar in your Pareto chart. The next one, you have these three numbers. Of course, 4.2 billion, which is administrative error, comes here as your third bar. The frequency is 4.2. So as you can see, we stop the bar at this number. Then you have 1.7, which is vendor fraud. Vendor fraud comes here. And finally, unknown factor, 1.1 billion. As you can see, it's from maximum to minimum frequency. So you have a decreasing pattern.
Is this always how
So on page 5, we have scatter plot. Scatter plot is very similar that you used in algebra. In algebra, you had ordered points and you graph them in XY plane. This is another name for scatter plot. Let us read this example. The British statistician Ronald Fisher introduced a famous dataset called Fisher's Iris dataset. This dataset describes various physical characteristics such as petal length and petal width. For 3 species of iris, they collected these data. In the scatter plot shown, the petal lengths form the first dataset and the petal widths form the second dataset. As the petal length increases, what tends to happen to the petal width? Okay, guys, here we have a table. On the left-hand side, on the first column, we have the length, and on the right-hand side, we have. So here you have the scatter plot. On the horizontal axis, you have the petal length, and on the vertical axis, you have your petal width. So how do you interpret this? Suppose the petal length is like 15, and your petal width is going to be a number here, like 1. So 15, 1. Suppose you take another petal length. For example, here for this point, which is 50. Then the pedal width is going to be, for example, 11. 50 and 11. Suppose we take another point in this graph. So take a look at this. Your pedal length is 60 and the pedal width is like 24 or 23. So 60 and 23. Do you see any pattern here? For a moment, forget about these points, these numbers. Think about it this way. Suppose you just try to see the direction of this line passing through these points. As you can see, here you have an increasing line. Since you have an increasing line, it means that your first variable, which is your pedal, this is your x. As x increases, your y, which is pedal length, increases as well. So the pattern that we see is an increase in the pedal width as the pedal length increases. Okay, let us get back to our note. And finally, we have time series. Time series and the example that I gave you about Apple MacBook are very similar to each other. In time series, you're trying to use time as hours, minutes, days, months, years to analyze behavior of your variables, data. Take a look at this example. Constructing a time series chart. The table lists the number of cell phone subscribers in millions and subscribers' average local monthly bills for the service. This is from years 2003 through 2012. Question says, construct the time series chart for the number of cellular subscribers. Year 2002, subscribers 134.6 million, average bill 47.42, and so on. Okay, take a look at the question again. Question says, construct a time series chart for the number of cellular subscribers. So your focus is on the first and the second columns. We don't care about average bill. We are using these two columns to actually construct a time series. Very well. On the horizontal axis, you have your years from 2000 to 2012. On the vertical axis, you have the number of subscribers. For year 2002, the number of subscribers are 134.6. So 134.6 is roughly here. So you have your first dot here. For the second year, 2003, and the number of subscribers are 148.1. This is your second dot. Then we connect them together. Then for 2004, 2005, 2006, based on the information that you have from your table, you plot each dot, then connect them together. So do you see an increasing trend or decreasing trend?
Yes.
Increasing.
Increasing trend. Excellent. Very well. Very well, everyone. So I want you to all to log into your Canvas.
Okay. Canvas.
Yes. And please go to modules. Which one?
Module. Week 1.
Yes. So before week 1, I created calculator instructions. You can click on calculator TI series getting started and click on this link. When you click on the link, it directs you to the virtual calculator. Now, please click on Get Started and enter your information here. First name, last name, email address, zip or postal code, the country, and the rest of the information. Here you can select student or other. So I'm going to use a fake name. As a student, then you can just select this as post-secondary, math, and then submit. After submitting, click on download software. So after entering the information, you submit it, and then you go to download the software. If you're using Mac product, click on the first one. If you're using a Windows product, click on the second one. Then it starts downloading the software for you. Then you need to install the software on your computer. After installing the computer, you should get this calculator here. This is an online emulator for you. So we're going to use our calculator to graph a histogram. First, we go to Stat, enter, randomly just plug in some numbers. These are the numbers that we entered here. Now, second, y equals to. We have different graphs here. I'm going to select the first one for my first data set. As you can see here, you have on and off. So I have to make sure the on is selected by entering. I'm using these arrows to go to the next line. And since I'm going to graph a histogram, I'm going to select my third one, which is a histogram, by entering that. Use arrow to go to the next line. Graph. If the graph doesn't show up, you need to click on Zoom 9. So Stat, enter. So now start typing some numbers. Very good, 44, enter. 55, enter. Any number, any setup number. Very good. Continue, continue. You need more numbers. 45, enter. Very well. 66, very well. Yes, 50, 55, 69. Very well. Repeat 63. Very good. 58, another 58. You can actually use your keyboard to type the numbers. 58, another 58. 89, very good. Another 89. Just give me some repeated numbers as well. 45, 45, 9, 94, 94, very good. 99, excellent, very well. Now, click on second y equals to.
This one.
Yes. And y equals to, on top of it. On top, very well. Click on that. Excellent, nice. Now click on enter. Down here, very well, excellent. Enter again.
Enter.
Yes, enter to select on, very good. Now use these keypads to go to the next line.
Keypad.
On top, very well, yes. The
This
second one down here, down, to go, very good, yes.
Just
Yes, just click once, very well. Now use the right hand arrow, stay there, stay there, stay there, right hand, right one. This one, right, on the right.
right.
Yes, excellent. 2 times. One more time. Yes, excellent. Now enter. No, you go further. You go further. Go to the left. Another left. Okay, perfect. No, go to the right. You need to select this histogram. Very good. Excellent. Enter.
Enter.
Excellent. Enter. Excellent. Nice work. Now click on the arrow. Go to the next line. Excellent. So stop here. Click on graph on top right. Graph. Excellent. Now click on zoom. Click on zoom on top, zoom. Very well. 9. Number 9. 9. Excellent. Yes.
Oh, finally I got it.
Made it. Go to your module and you see calculator instructions here. Here I have a calculator detailed instruction for you, which is a PDF file. On the exams, you need to follow these instructions to do the calculation or graphing. To practice using a calculator, I want you to enter the information, these numbers, into your calculators and actually construct a histogram.